Error trapping and handling in scripts. In this nugget, we're going to look at what to do about errors that occur while your script runs. And we're not talking here about logic errors or your script being broken. We're talking about errors that occur because of circumstances that you can anticipate, like a file not existing or a particular computer not being available when you try to connect to it. We'll start by looking at the differences between errors and exceptions, because that can kind of be a confusing part about the way PowerShell works. We'll look at the -error action parameter, which allows us to create exceptions that we can trap, and then of course we'll look at trapping those exceptions. Inside of a trap is where you deal with the error, either try again or maybe log an error to a file, and when you're done you want your script to try and continue doing whatever it can, so that's called exiting the trap. Now, Windows PowerShell has this concept of scope with errors, and that can definitely make it a little bit tricky to figure out where they're going to be dealt with. So we'll look at following trap scope. Now, when you're dealing with an error, you're going to want to know what the error is. So we'll look at reviewing and capturing errors, and when we're done, you'll have a great idea of how to add a trap to a script, anticipate an error, and deal with it. Now, to do that, I'm going to need a script editor, so we'll open up my script editor here. And we're just going to start with a simple command: get wmyObject win32 service from a computer name that does not exist. Now that's guaranteed to generate some sort of error or exception or whatever else. In fact, let's run that. And kind of the bad part about using this particular command to test with is that it does take a few seconds to time out, so you kind of have to be a little bit patient with it. The reason I like to use getWmyObject as my example, though, is because this error, the RPC server is unavailable, meaning that it wasn't able to connect to the computer, does not exist. This is really common. This is something that you're going to use a lot in your scripts. So although it will require a little bit of patience as we're kind of walking through this, it's extremely real world and extremely practical, and we'll be able to take this code and these traps we're going to write and use them in a lot of different places. So first of all, let's write a trap. You do that in the script by using the trap keyword. That creates a construct which is contained in curly braces. And we're just going to kind of do something simple here. We're going to write host couldn't connect. And we're going to do that just to kind of make it stand out a little bit. We're going to do it with a background color of blue. That way our text will be different from the red error text. So let's run that again. And again, it takes it a few seconds to time out. And I want you to think about what I was just telling you about the error action preference and kind of try in your head to predict what would happen. See, we got that red error message, but we did not get our blue couldn't connect. And that's because by default the error action preference variable is set to continue, which writes an error message but does not throw an exception. And it takes an exception to activate our trap. So there's a couple of ways we can force getWmyObject to generate an exception. The obvious way is to set error action preference equal to stop. So now when we run this again, we'll get a very, very different result. By setting the error action preference equal to stop, I'm saying when something goes wrong, go ahead and write an error message, but throw an exception. Do not try and continue. And there we go. Couldn't connect, with a background color of blue. We still got the red error message. Here's the problem with setting error action preference, though. That's going to be effective for every single command that runs in our script, and we don't necessarily want that. We might just want to worry about errors that we know we can deal with, or that errors we particularly want to pay attention to. So instead of setting that globally through our script, all these commandlets support an error action parameter. And if you don't feel like typing EA or error action, you can just type EA and just tell it the same thing, EA stop. So when I run this now, my trap should run. Great. And the only other thing we really need to figure out here is how to make that error message go away. I mean, let's say instead of writing a message, we're going to write the computer name that we couldn't connect to a log file. And that way we've got a nice text file listing all the computer names we had a problem with. But if we're going to do that, if we're going to take some action, we probably want this error message to kind of go away. Well, there's kind of a neat way to do that. And what we're going to do is set error action preference equal to silently continue. And in just a little bit we'll talk about why this works the way it does, but let's just run it and see if it does what we think. Again, so right now PowerShell is sitting there trying to connect to the computer, does not exist. We've told it that if a problem occurs to throw an exception, and so our trap ran, and we can prove it right here because we got our message. Because the overall script was set to silently continue, we were actually able to suppress the normal error message that would be displayed at the shell, and we replaced it with our own error message. If we didn't want an error message at all, we could just change what goes on in our trap. So that's kind of the key, that error action parameter and the error action preference variable. So let's dig out our trusty whiteboard and take a look at scopes. In Windows PowerShell, the shell itself, you can think of this as that console window, although that's not exactly right. This is the PowerShell engine. The shell is what's called the global scope. When we run a script, that gets its own scope called a script scope. Inside that script, we might create one or more functions, and each function is its own scope. So you can kind of see how this sets up a hierarchy. The global shell is the parent, and the script is a child, and the functions are children of the script. To reverse that, we might say that the function is a child of the script, which is a child of the global. And we can have multiple scripts. Each one gets its own scope, and whatever goes on in that script is isolated from what goes on in the first script. When an exception occurs, PowerShell looks for a trap in the same scope that the exception occurred in. So let's say we have a function and some sort of exception occurs inside of it. We don't have a trap inside the function, but we do have a trap out here in our script. So when the exception occurs, PowerShell looks. Is there a trap in the same scope? No. So at that point, PowerShell exits the function and goes up to the script, and the exception goes with it. So the function's over with now. In the script, it does find a trap, so it runs whatever code is inside the trap. If the end of that trap says to continue, we don't go back inside the function to continue, because we exited the function already. Instead, we're going to continue with the next line of code in the script after whatever line called the function in the first place. So let me kind of draw that out in code. Let's say I'm inside of a script. I have a trap, and we're not going to put any fancy code inside of it. We're just going to indicate that there's a trap there. And I have function A, and there's some code inside function A. And I have function B, and there's some code inside function B. And then down here in my script, maybe I'm going to write the number 1. Then I'm going to call function A, and then I'm going to call function B, and then I'm going to write the number 2. Now inside this function A, let's say I've got 3 things going on. I'm writing an asterisk, and then I'm writing a question mark. We're going to give ourselves a little bit of extra room inside the function. And then I'm writing, I don't know, a caret. Just some random characters. So here's how things go. I run the script. PowerShell sees that there's a trap here. That's great. It sees the definition for function A and function B. Wonderful. It sees write 1. So my first line of output is going to be 1. Then I execute function A. Let's say this first command goes off without a hitch, and my next line of output becomes that asterisk. But let's say for some reason an exception occurs with this write command. And let's say that I ran that with error action stop, so it's a real exception. Now, is there a trap inside function A? No, there's not. So this exception occurred inside the function, but it wasn't trapped inside the function. So now we're going to leave the function and go back up to the script. And we see that there is a trap in the script. So that exception is going to get handled here by this trap. At the end of that trap, if we said to continue, we're going to continue with the next line of code following the one that caused the exception. We can't go back inside the function. As far as the script is concerned, the exception occurred here, inside the function. So the next executable line of code is B. So whatever happens inside function B is going to run, and then when function B is finished, we write 2 as our next line of output. It can get a little bit tricky following these exceptions around. So kind of my best practice is, if you anticipate an error occurring, trap it inside the function. You can put a trap inside of a function. So if you're trapping it inside the function, then it kind of all stays a little self-contained. Let's take our example script here and sort of build this out to further illustrate that. I'm going to take away my error action preference variable. We have a trap defined. We're going to end it with continue, and we're going to change this trapped in the script, just so we know that that trap exists in the script's scope. Then we'll create a function called a, and in it we're going to run get wmyObject win32 process from a computer name that does not exist. And we're going to run it with an error action of stop to be sure that it generates an actual exception. Down here in the script, we're going to write host step 1. Then we're going to call function a, and then we're going to write host step 2. So let's run this and talk about what we think will happen. Well, line 11 ran, so we got step 1. Now line 8 is running, and when that exception occurs, there's no trap inside the function. So the exception was passed up to the script, and it was trapped in the script. And then line 13 executed. We can even illustrate that further by inside our function here, write host inside function step 2. And we'll do the same thing up here. Write host inside function step 1. Run it again. Okay, so step 1 executed. Then line 8 executed. We're inside the function. Line 9 is executing right now. It's trying to talk to WMI. An exception occurred. We didn't trap the exception inside the function, so we left the function entirely, and line 3 executed. Line 4 said continue with the next line of executable code, but that was not line 10. We already left the function. The next line of executable code was line 15, and so that was the next line that executed. Let's do one more thing. Inside the function now, let's trap write host trapped in the function with a nice background color of blue. At the end of the trap, we'll exit with continue. This time when we run it, okay, we still get step 1, that's line 17. We still get inside function step 1, that's line 12. We're currently executing line 13 of our script. Line 13 bombed. Then, because there was a trap inside the function, line 9 executed. Line 10 executed, which said to continue, which means line 14, the last line inside the function, executed. Then the function ended naturally, and line 19 executed. So that's kind of the difference. And scope really plays a big role in how and where you deal with your errors. So I'm going to discard those changes, and we'll look at the next bit, which of course is, now that I've trapped this error, what do I do with it? Well, you've really got two options. Let's start by running a command that we know will cause a problem. Let's do a short one that won't take a while. Get content c test.txt. Once that error occurs, it actually gets stored in a special variable called error. Here's the trick with that, though. Let me run another one. Let's go ahead and run our get WMyObject. We'll try and get win32 process from a computer that does not exist. So this is going to take a minute. The trick with $error is that it doesn't just contain the last error which occurred, it contains all the errors that have ever occurred, at least in this instance of the shell. If I look at $error now, there they both are. The neat thing is these are objects. If I pipe them to get member, you see that they've got properties I can work with. And if they're objects, then The 0 index is the most recent error. So that's one way of finding out what just occurred inside your trap so that your trap can decide what it wants to do. Was it a permissions issue? Was it a missing file issue? You can take different steps depending on what error occurred. Another option you've got, though, is to run the command with a special parameter called error variable, or if you don't like typing all that, just EV. Give it the name of a variable. No $sign here. It's just the name of the variable. And then when you want to get to it, you use the $sign. So that way you've got a specific variable which contains just the error that occurred to just that command. Inside of your trap, you would then have access to that variable so that you could look at the text of it, determine what went wrong, maybe take different action depending on different types of errors, and so forth. So that's really all there is to it. Decide where you think the errors might occur and anticipate errors, and make sure those commands run with EA stop. Inside the same scope, you then write a trap which is going to deal with your error. And at the end of that trap, you're either going to exit with continue if you want to continue executing in the current scope, or you're going to break if you want to exit the current scope. You can always use EV to capture the error into a variable that you can then review inside the trap if you want to take different actions depending on, different error situations. And at the top of your script, you may want to set that error action preference variable just to suppress any other error messages, remember, not exceptions, that might occur. So to do that, you would just set error action preference to silently continue. So that's kind of the summary of it. Really, the idea is to make sure that the trap is in the same scope that the error may occur in. So if you are anticipating an error inside of a script or inside of a function, trap it inside of the script or inside of the function. That way everything's kind of nice and self-contained. In this nugget, we learned how to deal with errors. We started by looking at the big difference between error messages and actual exceptions that you can trap. We looked at how to force an exception to be generated when something went wrong by setting the error action parameter on a commandlet. And when an exception was generated, we learned how to trap that. We learned how to deal with it in the trap and then exit the trap so that our script could continue if possible, or that we threw the exception up to the next scope. And that's where we learned about following the trap scope. So we learned about the hierarchy between the global shell and scripts and functions and how the trap can travel up that hierarchy. Once we trapped an exception, we looked at how to review it and capture it into a variable so that we could, deal with it more closely and use that information. And we kind of wound up seeing how traps are actually added to a script so that you can make them more robust and anticipate specific types of errors that might occur and provide some way to deal with them. I hope this has been informative for you, and I'd like to thank you for viewing.